let's do these two example problems. Solve. X squared minus 7x plus 6 equals 0 for x. This is our first example problem. And we're going to go through all of our steps. I'll remind you of what those are. Step number 1 is to make sure that there's nothing on the right side except a 0. Check. Step number 2, make sure that the equation is in standard form. Standard form, I'll write it up here so we can leave it up here, is ax squared plus bx plus c. Remember, a, b, and c can be positive numbers, negative numbers, fractions. It can be anything. And they're like the thing that's sitting in front of the x squared, the x, and then the c is actually just a number. So here in this example, what is a, what is b, and what is c? A is 1. What's b? Negative 7. And what's c? Positive 6. What's the greatest common factor of 1, negative 7, and positive 6? It's just 1. It's 1. There's no common factors other than 1. So these are called co-prime, relatively prime to one another because they have no common factors. The greatest common divisor of 1, negative 7, and positive 6 is positive 1. Therefore, we don't have to do that step. We move on to the next step, which is to factor the left side. Okay, so that's where we came over here and I did my squigglies. Step 1 of factoring is to compute the master product, which equals a times c, which is 1 times 6, which is 6. And step 2 is to factor the master product, in which case we'd factor 6. My factor pairs are 3 and 2. Negative 3 and negative 2, 1 and 6, negative 1 and negative 6. Step 3 of factoring is to add each factor row. So I'll add all these now. 3 plus 2 is 5, negative 5, 7, negative 7. Step 4 is to match with b. b is negative 7. So I'm looking for factors that add to be negative 7. Those factors are negative 1 and negative 6. So now I can exit the factoring subroutine, come back up here, and move on to my next step, which is to write in factored form. So there's my template, open parenthesis, close parenthesis, open parenthesis, close parenthesis, equals 0. Stick an X right here and an X right here. And now you copy and paste your factors right there, minus 1, minus 6. The next step is to set each factor equal to 0. So you set up these two little equations. X minus 1 equals 0, x minus 6 equals 0. Next step is to solve. So it's plus 1, x equals 1. That's one solution. Plus 6, x equals 6. That's another solution. We identify these solutions as solution 1, solution 2. And finally, we write it like this. Curly brace, open curly brace, which means the set of all, and then we write an x, the set of all x, and then we put a vertical line, the set of all x such that and then we write an x. The set of all x such that x, and then we put a colon. The set of all x such that x contains, and then we write 1, 6. Those are our two solutions, 1, 6. So the full sentence of the solution is the set of all x such that x contains 1 and 6. This is very important. It's very important that you understand what is happening graphically. So let's hop over to Dead Mouse. And we're going to type in this equation. Look at the laser pointer. We're going to write y equals x squared minus 7x plus 6. Back to Desmos, y equals x squared minus 7x plus 6. And let's go check to make sure that we got the right solutions. Did we? Yes, we did. Okay. Was that manageable? It's a lot of steps. I know. It's a lot of steps. If you count all the steps up, it's something like 12 or 13 steps per problem. It's a lot of steps to remember. But I promise you it is. I tried to watch some YouTube videos on the different rotation patterns in volleyball so I could better understand what these girls were doing. And I didn't understand, why is it that sometimes somebody is serving? Why is somebody wearing a different colored jersey? I tried to watch like an hour-long video on the rules of volleyball. I got to tell you something. I was completely confused. I did not understand any of it. I don't understand the rotations at all. So what I'm saying is, I understand this, but I don't understand the volleyball rotations. But anyone that plays volleyball does understand those. And so those are harder than this. So if you're playing volleyball or you play basketball, baseball, football, you know more steps than these problems require. So just have confidence that with time and practice, you too will become good at this. Just like you were probably, scared when the coach was screaming a play pattern to you, A4, A4, and you didn't know what that meant, and eventually you did. Okay, so next problem. Now this one's going to present us with a bit of a challenge, something new. Okay, solve 7x squared plus 21x minus 21 equals 7x FOR 4x. Okay, so this time we've got two situations. We've got stuff on the right side, and we have a leading coefficient for x squared that's greater than 1, which means we're going to have to look at greatest common factor. So first of all, the right side does not equal 0, so we've got to do that first. Subtract 7x from both sides. Make sure you line this up, minus 7x. Okay, line. This is 0. Now this 7x squared just comes down. We didn't touch that. 7x squared. 21x minus 7x. Well, that's plus 14x. and then minus 21 equals 0. Okay? Now we attempt to factor out a greatest common factor. Look at these A, B, and C positions. What's the biggest number I can pull out of each? 7. So here's how that looks, folks. Put parentheses around it just like I did, and then draw lines underneath each of your 3 terms. And then put a 7 here, and a 7 here, and a 7 here. Yeah, and what's actually happening is you're doing a reverse of distribution. You're pulling out the 7. So this is distribution in reverse. You're undistributing the 7. So now you're bringing that 7 back out here. And so these cancel, and you have x squared by itself here. And then 14x over 7 is 2x, so plus 2x. And then negative 21 over 7 is minus 3 equals 0. This is what you factor, okay? Factor this. Okay, this is what you factor. Factor this. We don't care about the 7, all right? We don't care about the 7. The 7 changes the way the problem looks, but it doesn't change the solution point. So the place where it crosses the x-axis will not change, even though we pulled out a 7. But that isn't to say that this smaller equation is the same as this equation. It's just that the solutions are the same. So we're going to factor this. So here's our little subroutine over here. Factor. Okay. We need to identify A, B, and C inside the parentheses. A, B, C. 1, 2, negative 3. Since we've already performed the greatest common factor test, we already know that these are relatively prime numbers to one another, and we can just proceed. What does MP stand for? Master product. So we compute the master product as A times C. 1 times negative 3 is negative 3. And now we factor that master product. And you list all the ways you can get negative 3. Like you can get it 1 and negative 3, negative 1 and positive 3. And to the best of my understanding, that's it. Now we add those. Negative 2 and positive 2. I'm looking to see if I have a factor pair that the sum is B and B is 2. Okay, B is 2. Well, that would be these over here, wouldn't it? Negative 1 and positive 3. So now I write in factored form down here. X equals 0. And I just copy and paste the negative 1 and the 3, positive 3, like this. X minus 1, X plus 3. Okay. We already know what the next step is. Set each factor equal to 0. X minus 1 equals 0. X plus 3 equals 0. And we're going to solve both of these for x. Add 1 to both sides here. and x equals 1. Subtract 3 from both sides here, and x equals negative 3. Remember, we label these as x sub 1 and x sub 2, and then we write our solution as follows. The set of all x such that x contains 1 and negative 3. And actually, if we want to be even more stylistically accurate, we list them in order from least to greatest. So we'd say x contains negative 3 and 1. It doesn't matter that order that you write that in, but the rule of thumb, I don't have a thumb here, but the rule of thumb is negative 3 goes first because it's smaller. Now we check on Desmos to make sure that we didn't make any kind of ridiculous mistakes. Here's a mistake that I don't want you to make. The equation you're going to plug into Desmos is this equation right here. You're going to write y equals 7x squared plus 14x minus 21. Y equals 7x squared plus 14x minus 21. And we see our first solution is negative 3 and our second solution is positive 1, which matches exactly. Now you see why we wrote them in order too, because that's how they appear on the graph in order. Remember, the most important rule, the most important thing to remember right now is this, and I want you to write this down because this has got to become part of your working knowledge, your memory. Okay, here's what you got to write down. The graph of y equals 7x squared plus 14x minus 21 crosses the x-axis at negative 3, 0 and 1, 0. Therefore, the solutions to quadratic equations are simply the x-intercepts of the graph. Remember, you have to show all these steps in my class, but on the STAR test, you go to Desmos, you type in y equals 7x squared plus 14x minus 21, and you click where they cross the x-axis, and just like that, you're done.